Hello ladies and gentlemen, we're going to do the last section in 14.1. We're going to graph our tangent curve today. So our objective is to graph that periodic function both by hand and in your grapher. And I'll actually do this one in our grapher because it's kind of cool to see. Alrighty. Alright, same as with the other two videos. The cycle is one complete pattern. Our period is the horizontal length of one cycle. But for tangent, amplitude is a little bit interesting. So we talk about amplitude a little bit differently when we talk about tangent. Alright, so I've already started with our unit circles. So I have 0, pi over 2, pi, 3 pi over 2, and I've listed my coordinates. So the first thing that we need to remember is that the tangent of an angle is opposite over the adjacent. So it's going to be y over x. And if we followed with our previous videos, then that means this would be sine of theta over the cosine of theta. Okay? So I'm actually going to use this particular ratio as I talk about tangent. And I'm going to calculate tangent at each of my points. So the tangent at 0 degrees, or 0 radians, is going to be y divided by x. So it's 0 divided by 1, so it's 0. The tangent at pi over 2 is still y divided by x, and it's 1 divided by 0. The world explodes, so we say that this one is undefined. And because it's undefined, it creates a asymptote, and it does happen to be a vertical asymptote. Okay? Then if I get to pi, the tangent of pi is going to be y divided by x, and it's going to be 0 divided by a negative 1 is still 0. The tangent at 3 pi over 2 is going to be y divided by x. So again, it's going to be a negative 1 divided by 0. It is a vertical asymptote, okay, because it's undefined. Can't divide by 0 because the world explodes. And then I would go back all the way around to 2 pi. Alrighty, so when we graph tangent, it's actually one of the easiest curves to graph because the first thing that I graph for tangent are my asymptotes. Okay, so I'm going to write my steps to graph tangent. Thank you. Okay, so I just have two little steps to graph tangent. The first one is I'm going to determine the period, and then I'm going to mark it on graph. And then my second step is I am going to determine the vertical asymptotes, and then I'm going to mark those on the graph. I'll make that an and mark on graph. Okay? Alright. So I'm going to actually show you what the graph looks like, and then I'll give you your generic equation. Okay. So if I remember the values, I'm going to write them here so we can see them. I know that the tangent is 0. I know that the tangent at pi over 2 is a vertical asymptote. I know that the tangent of pi was 0, and I know that the tangent of 3 pi over 2 is a vertical asymptote. Okay? So here's what the graph of tangent looks like. Alrighty. So I know that I'm going to have a cross at 0. I'm going to have a vertical asymptote at pi over 2, so I'm going to draw in a vertical asymptote. Okay. I'm going to cross again at pi, so I'm going to put a dot there. Then at 3 pi over 2, I'm going to have another vertical asymptote. And then my next point would be 2 pi, and I would have a dot there. So here's the way tangent looks. It's going to be from here to here, and then it's going to cross, and then it's going to cross. Okay, and I could keep going in either direction, and then that would give me more information about my curve. So let's talk about the amplitude first. So if you'll notice, these curves get really, really close to the vertical asymptote, but they're never going to cross the vertical asymptote. Therefore, the vertical asymptote pushes the curves and defines the shape. Okay? So in theory, these values continue forever and ever and ever, so that's why we really don't talk much about the amplitude. It is still A, but because the graph continues forever vertically, it's really kind of irrelevant. All right? If I had a negative A, it would reflect my graph, so then it would be I'll draw it in orange. This would be the reflected version of my graph. So that's kind of cool. Okay, so if it was a negative a, I'll put my a in orange so you can see it. The period for tangent is different. So notice I have one curve and the bottom, so these two pieces make up one complete cycle. So the period for tangent happens by pi. So unlike sine and cosine, where it takes it 2 pi to get one complete cycle, tangent has one complete cycle. I have a top and a bottom of the curve by the time that I get to pi. And then I have a handy dandy little equation for my asymptotes. It's going to be pi over 2b, or if you think about if I graph my period and then cut it in half, that's going to be where my asymptotes are. The asymptotes for tangent kind of become your counting fractions, okay? And that's how I do it anyway. Alrighty. I think that's all of our generic information for tangent. Okay, you do have to show your asymptotes as a dashed line. You do have to show your curves crossing the x-axis and approaching your asymptotes. So that would be my expectation when we do some problems. Alright, so I'm only going to do one other example for you because tangent's really the easiest of the 3 to draw. So I want to draw or graph 2 complete cycles. And of course I want to label well, okay, and I'm going to have y is equal to a negative tangent 4x. So my amplitude is 1, so I can still talk about the amplitude, although it's really not very descriptive because my graph continues forever up. I do have a reflection across the x-axis, and I'll actually graph this one in my calculator for you. Alright, my b is 4, therefore my period is going to equal pi over b, which is pi over 4. My asymptotes are going to occur at pi over 2b, so it's going to happen at pi over 8. So my pi over 8 is actually going to be my counting fraction. So I'm going to put pi over 8, and I'm going to add an asymptote, okay? And then my period is pi over 4. Notice this is half of my period, so this is 1 pi over 8, 2 pi over 8, 3 pi over 8, and if you'll notice, my asymptotes are occurring at the odd multiples, okay? And then this one would be 2 pi over 4 or 4 pi over 8. So I want 1 period, 2 period, okay? All right, my amplitude I really don't have to show on my y-axis for tangent, but remember I did have a reflection, so that means my tangent curve is going to start going left to right, okay? And then now I have shown 1, 2 complete cycles. So when you take a quiz or test for me, if you actually just draw a bazillion, I would actually count off for that because I want you to be very precise about drawing your 2 cycles. And again, I could go from left to right. Alright, so let me show you this in my grapher. So the first thing I'm going to check is that I'm in radians and function mode. So I'm going to go to my y equals and I'm going to clear and I'm going to enter negative tangent of 4x. And then I'm going to go to my window and I'm going to graph from x is equal to 0, and then we went to 2 second pi divided by 4, okay? And then my x scale I'll leave as a 1. My y minimum, I kind of don't care. So I'm just going to leave it like that, and then I'm going to graph. Alright, so there's the bottom. Here's my next one, and then there's that top half. So if I zoomed out a little bit, instead of having a very specific window, then I could see more iterations of the curve. So that's a pretty cool toy. Alrighty, notice again that it is a periodic function. The pattern is repeating, and it will keep repeating forever and ever and ever. Alrighty, let me give you your problems. Again, another nice short video, which is glorious. Okay. And our school year is approaching a close, so even better. So I want you to sketch 2 complete cycles by hand. Okay. Of course, you have to label your critical points. So for tangent, sorry, let me complete that thought. Label the critical points. So for tangent, that's going to be your asymptotes and the period, and those are the only critical points that you actually have to label. Okay, and you do have to label them completely for both cycles. Your first problem is going to be y is equal to the tangent of 1/2 x. Number 2, y is equal to the negative tangent 2x. Number 3, y is equal to the tangent of 2 pi x. And then the last problem, y is equal to a negative 3 tangent 3x. Alrighty, good luck with your problems. Nice short video, and I will see you tomorrow.